Alright, so the first section that we're dealing with tonight is 0.1 simplifying fractions. So before we talk about fractions, we want to talk a little bit about whole numbers. And let's see here. So it says whole numbers are the set of numbers 0, 1, 2, 3, 4, 5, 6, 7. The little dots just mean that this goes on forever. And it says whole numbers are used to describe whole objects or entire quantities. Fractions are a set of numbers that are used to describe parts of the whole quantities. It says in the object shown in the figure, there are 4 equal parts. 3 of the 4 parts that are shaded represent the fraction 3/4. In the fraction 3/4, the number 3 is the numerator, the number 4 is the denominator. So again, it tells us right here, the numerator is the number on the top, and the denominator is the number on the bottom. So natural numbers or counting numbers are like the set of whole numbers, except we don't have 0. We start counting at 1. So 1, 2, 3, 4, 5, 6, so on and so forth. It says when 2 or more numbers are multiplied, each number that is multiplied is called a factor. So if we write 3 times 7 times 5, each of the numbers 3, 7, and 5 are called factors. Prime numbers are natural numbers that are greater than 1, whose only natural number factors are 1 in themselves. For instance, the number 5 is prime. The only factors of 5 are 5 and 1. We can't break down 5 other than using 5 and 1. The number 6 is not prime. We can break down 6. Besides 6 and 1, we can go 2 and 3 or 3 and 2. And it gives us a list of the first 15 prime numbers here, okay? So the first couple of problems we're going to deal with here refer to simplifying fractions. Simplifying fractions just means we're going to try to reduce those fractions, okay? So one thing we can do is we can say 14 and 21, do they have any common factors? So when I think about common factors, what I want to think about is I'm going to pull up a multiplication table, and I want to look at 14 and 21. I want to see if I can find 14 or 21 anywhere in here. And if I look here on my number 7s, here's a 14 and here's a 21, which tells me that the numbers 14 and 21 can both be divided by the number 7. So 7 goes into 14 twice, and 7 goes into 21 3 times. Let's do the same thing here for the fraction 15 and 35. So I'm going to go back to my multiplication table. Again, you can print this out. I have it there in our notes. So I'm going to come back to my multiplication table. 15 and 35. Here's 15, here's 35. They can both be divided by the number 5. So if I come back to my problem here, well, 5 goes into 15 3 times, and 5 goes into 35 7. All right, let's do this a third time, 20 and 70. Again, what I want to do, I'm going to refer back to my table, right? 20 and 70, I can divide them both by 10. Okay, so let's come back over here, and we can say, well, look, you know what we're going to do? We're going to go ahead and divide them both by 10. So 10 goes into 20 twice. 10 goes into 70 7 times. So that's all we're really doing simplifying fractions. I think the easiest thing to do when you're going to simplify a fraction is use that table. It's going to help you out a whole lot. Okay. Let's do the same thing here. Let's simplify fractions, okay? So 7 and 21, if I look at my table again, I can divide them both by 7. So 7 goes into 7 once. 7 goes into 21 3 times. Okay. Let's take a look at 15 and 105. So if I pull up my chart again, here's 15, here's 105. If you notice, I can divide them actually both by 15. All right, so if I look at 5 here, I do see my 15. I don't see my 105. I know it would be in this list, but I want to see if I can divide it by the biggest number. And 15 appears to be the biggest number. So 15 goes into 15 once. 15 goes into 105 7 times. So when I come back to my problem here, 15 goes into 15 once and into 105 7 times, and there's my answer. Okay. All right, let's take a look at this one here. We can divide them both by 7. So 7 goes into 35 5 times. 7 goes into 7 once, but 5 divided by 1 is simply the number 5. Often people ask, do I need to write it as a whole, do I just need to write it as 5, or can I leave it as 5 over 1? Anytime you have that denominator of 1, you want to go ahead and just write the whole number, okay? Same thing here. We know 10 goes into 77 times. I can just leave it like that, okay? All right. Let's take a look at the next problem here. It says, to change an improper fraction to a mixed number, divide the denominator into the numerator. The quotient is the whole number part of the mixed number. The remainder from the division will be the numerator of the fraction, and the denominator of the fraction remains unchanged. Okay, so let's see if we can make sense of what is that actually telling me here, okay? So we're going to divide the denominator into the numerator. So I'm going to go old school style. Here's my number 7, divided by 4. 4 goes into 7 one time. Put my 4 right here. Remember what we do here? We subtract. My remainder, 7 minus 4, is 3. Okay. I'm going to use these 3 numbers here to write it as a mixed number, okay? So what I'm going to do is I'm going to say, okay, that number 1, that's my whole number part. The remainder is the number that goes on top. The denominator remains unchanged. So that stays a 4. Okay. Let's do the same thing for the next one. Now notice what it says. Change to a mixed number or a whole number. Well, I know 3 goes into 15 nice and neat just 5 times, okay? So here's my answer for this one, and there's my answer for that one. Okay. All right, now we're going to go backwards. We're going to change a mixed number to an improper fraction. It says multiply the whole number by the denominator, add this to the numerator. The result is the new numerator, the denominator does not change. Okay, so we're going to go through this in pieces. Multiply the whole number by the denominator. Here's my whole number. I'm going to multiply it by the denominator. So 7 times 3 is 21. Add this to the numerator. So 21 plus another 1 is 22. That is my new numerator. The denominator does not change. That stays a 7. Okay. Let's do the same thing with this problem. We're going to multiply the whole number, that one, by the denominator. So 5 times 5 is 25. We're going to add it to that number. 25 plus 4 is 29. The denominator does not change. That stays as a 5. Okay. Alrighty. So now let's take a look at these. It says find the missing numerator. Okay, these problems here, I like to call them stare and compare. Okay, I'm going to do a little stare and compare. I'm going to look at this denominator here, and I'm going to look at this denominator here. Now I'm going to ask myself, what did I multiply 5 by to get 25? Well, I had to multiply that bottom number by 5. Well, if I multiply the bottom one by 5, I got to do the same thing to the top. So 5 times 3, that'll leave me as 15 over 25. In these problems, we're not going to be reducing. We're actually going backwards. We're building up the fractions. Instead of making them smaller, we're going back. We're making them a little bit bigger. I'll do the same thing here. Look, 7 and 14. So 14 is bigger than 7. So we're building it up. What did I multiply 7 by to get 14? I multiplied it by 2. So I better multiply that number by 2 also. That leaves me with an 8 over 14. Okay. What did I multiply 9 by to get 36? Again, if you need to check, come back, pull up your table. Okay, so here is my number 9. What did I multiply 9 by to get 36? Oh, there it is. I multiplied it by 4. So I'm going to come back to my problem again. I'm going to say, okay, look, I multiplied this number here by 4. So I'm going to multiply that one by 4. So 4 times 9, yep, it's 36. 4 times 2 is 8. All right. And let's do the last ones down here. So again, I'll do the same thing. What do I have to multiply 8 by to get 24? I got to multiply it by 3. Well, then I got to multiply that top one by 3. That gives me a 9 over 24. 6 times what gives me 30? 5. So 5 times 6 gives me 30. 5 times 5 gives me 25. Okay. Look at the next one. What do I need to multiply 7 by to get 56? Again, if you're not sure, look at your chart. Here's 7. Scroll down until you find 56. There it is. What do we multiply it by? Multiply it by 8. The chart, to me, works so much easier than a calculator because you can see it. So I'm going to multiply that by 8 and that guy by 8. So we already know we have our 56, and 8 times 2 I know is 16. And that's 0.1.